So, today we have moved to the sixth lecture of this series, that is basic signal system. So, again we were looking at the few numerical problems on signal operations. So, today also we will see how we can apply different operations on a given signal with the help of numerical problem. See, we have solved this one, which is synthesize. We were given the waveform and we were required to draw those waveform using the elementary signals, or we were given the signals and we were required to write the mathematical form. Now, also we have seen how we calculate average. Now, moving ahead, now we are required that if a signal is given and we are required that what is the category of the signal, whether it is energy signal, power signal, neither energy nor power signal, how we will do, we will see. Suppose now see, suppose there is a signal like this, a signal given like this, and if I ask you tell me whether this signal come under the category of energy signal, power signal, or neither energy nor power signal, then how you will say. So, this is basically, or if a signal is like this, or if a signal is like this, or so if I ask you, these are the various 4 signals. If you are required to identify the category of the signal, energy, power, and neither energy nor power signal, how we will do, we will see. So, to remember this, basically you have to require to learn 3 rules which will help you in identifying the signal category. So, for energy signal, remember any signal. So, first of all, see, neither see, if any signal is having amplitude infinite in any duration of time or at any instant of time in a given waveform, if a signal is having infinite magnitude for any duration or for any instant of time, then we can say that the signal is which signal, neither energy nor power signal. So, the very easiest way to identify is neither energy nor power signal. What we have to do? We have to see, just you have to see a signal where if a magnitude is infinite, then we can say this is a category of neither energy nor power signal. See how, for example, if we consider tan t, ramp signal, these all are the category of what? Then parabolic signal, these all are the category of neither energy nor power signal, because how, see how will dot tan t is like, then ramp is like this, t square is like this. So, in all the 3 waveform, what we will see that the at one instant of time or at instant of time, the magnitude is going to infinite. So, that means that here we can infer that the signal is which category, neither energy nor power signal. Now, second one, see, second is the energy signal. So, for energy signal there is 2 condition, for energy signal there is 2 condition. First, for any signal having finite duration, or second, if duration is infinite. Suppose if duration is infinite, then it must be decreasing in nature, it must be decreasing in nature. So, if signals have to satisfy either of these criteria, then we can say the signal is the energy signal. Okay. See, let us see few examples. If we see, this, any finite duration signal, this is a finite duration signal we can say, or finite duration signal, or any signal. Suppose this is if you write e to power minus 80, this is how we write e to power minus 80. So, this signal is having what? Decreasing magnitude. Also, if there is a periodic signal, if there is any periodic signal, for example, or see, and this was the first condition where the duration was finite. Now second category, if the signal exists for infinite duration, what do you know infinite duration? See, if you draw a sinusoidal signal, if you draw a sinusoidal signal, so you can say the sinusoidal signal exists from minus infinite to plus infinite. That means the duration of signal is infinite, from minus infinity to plus infinity. Since the duration is infinite, in this case how we will identify? See, since in this case, what was the second criteria? Second criteria was, if the signal is existing for infinite duration, then that magnitude, the magnitude must be in decreasing order. But here you can see the magnitude is constant, or the signal is not decaying, it is generally following a same path. So that means this is not a category of energy signal. So few example, if you draw, see, suppose I draw signal like this, then you can see this signal is also existing from minus infinite to plus infinite, but the signal is what is decaying in nature, So we can say the signal is energy signal. Again now see, but if you have signal like this, see, if signal like this, that means this signal is of what nature? This is not decaying, it is expanding in nature. So it is not of a category of energy signal. And any signal which is not satisfying the criteria of energy and neither energy nor power signal, we can say that energy is a power signal. See how, example of power signal, how we will say, suppose you have a pulse of signal, a signal pulse like this. So see, if you first check for energy signal, whether it is energy signal, no. How? Why? Because as a signal is having infinite duration, okay, but the magnitude is not decreasing, then it means it is a category, it cannot be a energy signal. Whether it is having finite duration, but the duration is from, has a finite magnitude, but the duration is from minus infinity to plus infinity, so it cannot be an energy signal. Also, now check for neither energy nor power signal, whether the signal is having value infinite at any duration of time, no. See, magnitude, maximum magnitude is what? Is around 1 or 2, maximum magnitude is finite. So we will say it also does not fall in the category of neither energy nor power signal. So what it will be? It will be power signal. Also other way, see, what is power signal? What is power signal? See, any signal having power finite and energy infinite, and that will be category of what? Power signal. That will be category of what? Power signal. So if you require to find the energy of the signal, how will find the energy? This is finding the energy, minus infinity to plus infinity. So as the signal duration is from minus infinity to plus infinity, then E will be what? E will be infinite. So here also we can say the signal is a category of power signal. Also see some more examples. E to power minus t, what is the nature? What is the nature? As magnitude is decaying in nature, so it will be energy signal. Now take another example, ut, unit step signal. See, signal is existing for infinite duration, but it is not decaying, means it is, or also it is not having at any duration of time, it is not having magnitude infinite, so it will be category of power signal. Third one, RT, ramp signal. See, the signal is having magnitude infinite, at some time the magnitude infinite, means the signal is having value of infinite at a time, at duration of time, at a particular time. That means this signal falls under the category of neither energy nor power signal. Okay. Next, finding average of, again I have already told how you will find the average. Find the area, average will be area upon time duration. We have already seen this. How you have to find the average is area upon time duration. Now finding energy. Suppose I will find the energy, let us see. See, here also we can see energy. Suppose a signal is given, also let us see what all things. Suppose if a signal is given and we know the energy of that signal, and we are required to find, or suppose if we know that a certain signal is having energy E, and if we are required to do some operation on this given signal. A signal is given and we know the what is energy of that signal, but we are required to do certain operation on that signal, and after the operation we want to find that whether the signal is having same energy or energy has changed. Then what we will do, see, we will see here, see a signal is having energy E. Suppose this is a signal, it is having energy C E, and if we have what we have done, if we do the time reversal, suppose this is a signal, and if we do time reversal, if we make it like this 0 to 2, 0 to 2, or if we make amplitude reversal, if you do what we do, if we make amplitude reversal, this is x minus t, this is minus x t, or we make both, if we do both time reversal as well as magnitude reversal, this is minus x minus t. So, we can see, you can see, then even if you do so these operations, time reversal, amplitude reversal, time, or if you make time shifting, if you shift signal towards left minus 2 minus 1 minus 3, then you can see these 5 operations, that is time shifting or time scaling or amplitude reversal or time reversal, does not have any effect on the energy of the signal. Why? Because in all the cases, see what is energy? Area upon time, area upon time. So, until and unless you change the time duration or you change the area, the energy is not going to change. So, in all the cases, in all the 5 operations, the value of energy remains same, because the area has not changed, because the area has not changed. So, from here we can conclude that energy calculation is independent of time shifting, time reversal, amplitude reversal and other. Okay. So, if you take some other examples, or also suppose if we want to make what time scaling, suppose x t is this, if you make here x 2t, then what will happen? X 2t will like this, this will be x 2t, this will be x 2t. So, how will I write x 2t? X 2t is basically, now find the energy. So, energy will be area upon time. What will be the area? Area will be this is area square upon time. Energy is area square upon time. Okay. So, area square upon time, what is the area? What is the area basically? If this is 1, so 1 upon time is 1. This is basically energy for the modified signal. And what are the energy for original signal? Find the area square. It was 2 upon time duration, 2 upon 2 area is area squared 2, 4 upon 2, it is 2. So, we can only change the value of energy once we do what? Time scaling. And by what value the energy will change? So, we will see if x t is having energy E then x a t will have energy E upon A. Okay. So, by the value by which you do time scaling, your energy will be divided by same number. Okay. This is energy calculation. Similarly, for power, what we do for power, suppose any signal is given like this, or okay, let us draw it in small parts. Let us draw 4 signals. Signal 1, signal 2, signal 3, signal 4. So, I have drawn 4 signals. Okay, I have drawn 4 signal and we are required to find the power. So, what is the formula for power? So, power is square dt 1 upon t minus infinite to infinite. Okay. So, this is value for power. Power is basically what? Energy upon time. So, energy is what? X t square dt upon 1 upon t. This will be the duration, t naught duration. So, this is power. So, now see, I have drawn 4 signals, one this type 4 of signal, and if you are required to find the area of this signal, let this magnitude be 1 1 1 minus 1 or 1. So, if you find the area of the signal, you will see, suppose if this signal is having power p, then area, if you find the power of this signal, then in all these 4 cases, power will be same. In all the 4 cases, power will be same. How power will be same? See, if a signal, because while finding the area, while finding the square of the area, see here what you are doing, you are doing x t square of the signal. So, if you are doing a square of any signal, that means the negative part, if a signal is having negative part, that will also be coming into a summation. It will not be subtracted from the total area, it will adding to the given signal. So, that means if any signal is having same magnitude, what do you mean by modulus is same? If any signal modulus C, if you find modulus of the signal, so in all the 3 cases, we will see that the signal is having same modulus. But if we consider this signal is having half the modulus of these 3 signals. So, for these 3 signals the power value is same, and for this signal power is basically half of the 3 signals. Okay. So, if the power, so also power is p, here also p, here also p, and for this is p by 2. It is p by 2, because see there is 0 signal for negative time, there is 0 signal for half the duration. This signal exists for 0 to suppose 6, then from half time, that is from this 3 duration is having 0 signal. So, the power, that is x t square value will get reduced. So, power will become 1 by 2, that is power will become half. Also, power calculation is also independent of time shifting, time scaling, amplitude reversal. The power is also, see what is the difference between energy and power signal? If we talk of the operation in energy signal, whenever we are doing time scaling, the value of energy was getting reduced by the factor by which the time was scaled. But in the case of power signal, the power of a signal is unaffected by doing any time scaling, because that same factor of time is also coming in the denominator. So, it will not change the value of power. Okay. But in the case of energy signal, energy will have to reduce by same quantity by which the scaling is done, whereas in power signal it is unaffected by time scaling also. Okay. Okay. So, take some few more examples. So, now let us conclude all the 3 points what we have studied. We studied average, energy and power. Okay. So, average was unaffected by time shifting. Okay. And also suppose if xt is having as average 4, and also suppose you are given mathematical form and you are required to find the average energy of power. Suppose a signal is given xt and average value is 4, and if you are required to find x minus 2t, average of x minus 2t. So, as you know, the average is unaffected by time scaling. So, you can say average will remain same. Again, if someone asks you t minus 2, what is the value of this average? Here also we will have same value. Why? Because average is time is independent of time scaling or shifting. Both exist for case of energy and power signal. Both at least means all three categories of signals, average of the signal, energy of the signal and power of the signal, all the three are unaffected by time shifting. Okay. Second thing, now suppose a signal is given and we are doing any time scaling, then time scaling what which is getting affected, which is not affected. See, energy and power, first consider energy and power. So, energy is basically affected by time scaling, and by what factor? E. Suppose if xt is having energy E and we are required to find x a t, then it will be E by A. So, energy will reduce by the factor by which time scaling is done. Also, for power. So, finally, average power, energy, time shifting, amplitude reversal, time scaling, so you have to find which of the operations affect the value of energy and unaffected. So, energy is unaffected by time shifting, unaffected by amplitude reversal, unaffected by time reversal, only it is affected by time scaling. whereas for power signal it is not affected by any of the operation. So, here we can say we have to remember all these 4 properties by which we can identify the final value of any given signal. If a one form of signal is given and we are doing some operation, so we are not required to solve that waveform again to find the energy and value of energy and power. We can easily remember from this properties or from this table also we can easily say that whether the value will change or it will, if it change by what value it will change, and if it is not changing then what will be the final value. Okay. So, this was all for the today's lecture, and in next lecture we will see the basic system properties. Till now what we were doing, that we were studying about the signals, what were different operations we can perform signal, what were the classification of signal, what were the various factor, various identification through which we can identify the category of signal, how we can represent those signal into mathematical form, how we can represent a signal through its waveform, or if we are having any waveform and we are transforming it to another waveform, then what will be the change in energy, change in its power, change in its average or change in its area. But in the next lecture, from now onwards, in the next lecture what we will study about the system properties. System properties means, like as we are having properties for signals, classification of signal, similarly we have some properties attached with the associated with the system, like a system is static system, dynamic system, a system is time invariant system, time variant system, whether a system is LTI system or non LTI system, or whether a system is causal or non causal, anti causal. These are the different properties which are associated with the system, because we know if you are having any system and you are getting some output, it means that output will be because of the properties of this system. So, these are the various property and we will see in the next lecture.